Reaction mechanism E1E2. So the question is predict the product formed by the elimination in the following reactions and as indicated as E1 or E2. Okay, so really there is not much to think about over here except the fact that you have a substrate given to you, you have a nucleophile given to you, and you're asked to write the product using E2 mechanism. So when you're thinking about an E2 mechanism, you're thinking about a one-step mechanism, okay, in which case that here is the hydrogen that has to leave. Remember, it's a 1-2 elimination. So in E2 elimination, everything will happen at the same time. For an E2 mechanism, you also want your hydrogen to be easily accessible. All right, not for E1, E2 you do. Okay, so which means it's going to be the least sterically hindered hydrogen, okay, that you will be getting rid of. We don't need to write the mechanisms, okay, for all of these. We're only supposed to write the products, but I'm just going to write the mechanisms so that you can kind of see how to think about this if you want to. So in any case, here is the nucleophile. So the nucleophile, which is really going to be more like a base because we are not really doing any substitution here. So the base is going to go for the proton leaves its electrons here, and then the bromine is going to leave. So everything happens at the same time. So 1, 2, 3, 4, 5, 6 carbons that I have here. And so draw the 6 carbons out, and my double bond is going to be here. So this is going to be the Hofmann product, okay, that we form because this is the less sterically hindered proton that left, okay, and so Hofmann product is going to be the product for the first one. Let's look at the next one. This is an E1 reaction, and in E1 you have to go via the carbocation mechanism, which means that in the first step the bromine is going to leave. So as soon as the bromine leaves and you form a carbocation, you also lose the stereochemistry, okay, so now it doesn't really matter what I do here. So I can just write out like this and draw my carbocation here. I don't need the stereochemistry anymore because the carbocation now is trigonal planar, okay, it's sp2 hybridized. So that's what this carbocation is like. So now what I have to do is I have to do elimination because that's what I'm told. So once I have that, I'm going to get any hydrogen now. Most of the times, you know that in E1 mechanisms, you're going to form the Zaitsev product, okay? And the Zaitsev product is going to be the one that is the most stable alkene, all right? So that's the product that you need to form. We're going to form all of them, okay? And then we'll see what happens. So here's the base or the electrons over here. They're going to pick this hydrogen up over here, and then you lose this, okay? So I'm going to write the top product that I just made over here, okay? I also have other hydrogens because I'm looking for a beta hydrogen. So remember, it's a 1-2 elimination. The alpha carbon is the one where the leaving group is, okay? The beta hydrogen is where the carbon next to the alpha carbon, okay? So I have a beta hydrogen on this carbon. I have a beta hydrogen right here. That's beta, and then right here, this hydrogen is also going to be a beta hydrogen, okay? So I eliminated my first beta hydrogen using this one, okay? Now I'm going to go ahead and eliminate the second one, okay, which is going to be now this one. So if I remove this one, I'll form the double bond down here, so which means that this is what the product will be like. And then the last one that I have is this proton right here. So if this electrons, they pick up this proton right here, then in that case, my product will look like this. Okay, and so now we have to think about, okay, which is going to be the major product here, because that's one of the issues with E1 reactions, okay, is that you're going to get many products and then you have to decide which is going to be your major product, okay? So your major product is going to be the Zaitsev product, which of course this is the Zaitsev product and then this is the Zaitsev product, okay? So which of these two alkenes is more stable? Well, both of them are almost equally stable, but I would say that your major product is going to be this one, okay? This is more stable than this. So this is major, this is the next major, and then this is going to be the most minor because this is going to be the Hofmann product. Okay, this alkene is the least stable one. So that's something you have to remember when you're doing E1 reactions. We did not have to think about this when we were doing the E2 mechanism. Okay, let's look at the next one now. And in this case, we have a tertiary halide. So which means that as soon as the chloride leaves over there, then we have something like this. Okay, so iodide here is my base. So again, the first thing that I always do is I look for my beta protons. Okay, and so here is the beta proton because this is the alpha carbon right here. And then I'm going to also look for other beta protons. So I have a proton here and I have a proton here. And if you agree with me, and I really hope you do, is that these two protons are alike. Okay, and if you're not sure, you should draw the product out. Okay, so these two protons are going to be alike, which means they'll give us the same product. So let's go ahead and write the first one out, which means that this hydrogen is being picked up, and so the product you end up getting here is going to be this one. And then if the purple one is being picked up, which means this one, then the product you will get is going to be this. Okay, and in case of E1 mechanisms, again, your Zeitgeist product is going to be the major product. Okay, so this is your major, this is the minor product. Should you always write the two products? When you're doing things on your own, yes, you should. In an exam, you may have a multiple choice and we are asked for the major product. So then in that case, you will just have the major product. If you're asked to write all the products formed, then you should write all the products formed.